Good day to everybody. So let's continue with our lesson. So during the last lecture meetings, we have discussed special types of factoring. We have common monomial factor, we have the difference of two squares, we have perfect square trinomials, and then we have the trial and error method. So for today, we will be introducing what we call factoring by grouping. And normally, we use factoring by grouping if all the other types fail in the problem. But of course, it is not an assurance that if the other types fail, automatically the factoring by grouping will work. It really depends. So every time we do factoring, it is really very important that we are very observant with the elements given with the uh, expressions we find in the polynomial. Okay? So under factoring by grouping, from the name itself, we now need to introduce grouping. So we group terms together. But before we proceed with factoring by grouping, let's just review how we group terms in algebra. So in grouping terms in algebra, it was mentioned there that we can insert signs of groupings in a given polynomial. But of course, our sign of grouping can either be preceded by a positive sign or it may be preceded by a negative sign. So what's the rule? So whenever you are grouping terms and if the group is preceded by a positive sign, the terms inside the sign of grouping will have their signs unchanged based from the original expression. Okay? But if we are grouping terms and it is preceded by a negative sign, then all the terms involved in the group will now be changed in terms of their signs. Okay? So we are basing it from the original expression. So again, that's a basic rule in grouping. When terms are grouped together, preceded by a positive sign, the signs of the terms involved will remain unchanged. But if we are grouping elements preceded by a negative sign, then all the terms involved inside the group will now be changed in terms of their signs. Okay, so let's now proceed with some examples on factoring by grouping. Let's start with this first example wherein let's say we are given AB minus AC plus B squared, let's say, minus BC. Okay, so if we will try to observe this, going over the things that we have discussed, of course, the first thing that we have learned before is factoring by common monomial factor. So we really need to inspect. So common monomial factor is we inspect each term in the polynomial. We must find a common factor or a common element in each of the expression. So if we will try to observe this, for the first two terms, we have A as a common element, but we don't find A in the last two terms. Therefore, we cannot factor out A. We can find B in the last two terms, but we cannot find B in the second term. So we can also not factor out B. So we cannot find a common factor from every element present in the polynomial. Therefore, common monomial factor will not work. Let's proceed with the next. Difference of two squares. So obviously, difference of two squares will not work here because difference of two squares involve two perfect squares. We have four terms here, so definitely difference of two squares will not work. And then perfect square trinomial. We have four terms here. A trinomial in will have three terms, so definitely this is not a perfect square trinomial. Factoring by trial and error method will also not work because factoring by trial and error method normally works for trinomials that are not perfect square trinomials. Okay, therefore, If those basic types of factoring will not work, let's now introduce factoring by grouping. So in factoring by grouping, we can inspect our polynomial. We can group terms together so that when we group terms together, we can now apply our basic factoring. So we can either apply common monomial factor, uh, difference of two squares, perfect square trinomial, etc. Okay? So if we will observe this expression, in the first two terms, A is common. In the last two terms, B is common. So that should already give us a hint. So what we can do for this expression or for this polynomial is we can group together the first two terms, and if this will now be preceded by a positive sign, so it's implied that this is preceded by a positive sign, the terms remain unchanged. AB positive minus AC. Okay, then for the last two terms, we can also group them together preceding it by a positive sign. Therefore, the elements inside the sign of grouping will remain unchanged. Okay? So, after grouping the first two elements together, we can apply common monomial factor type 1. So, we can factor out A. So, if we factor out A, AB divided by A will be B minus AC divided by A will be C. So, we have factored out A from this group. And then for the second group, applying again common monomial factor, we can factor out B. So that will now be B multiplied by B minus C. So B squared divided by B is B, BC divided by B is C. Then after doing that step, you will find in the resulting expression that B minus C being grouped together is a common factor for the resulting expression or for the resulting polynomial. Thus, applying common monomial factor or applying type 1 of factoring, we can now factor out B minus C. So if we factor out B minus C, A times B minus C, if we divide it by B minus C, that should leave us A. Right? So if we divide this by B minus C, that leaves us A plus we divide this by B minus C, that should now leave us B. Okay? So we have used common monomial factor in this line of the solution. And this will now be our final answer. So remember, whenever you are instructed to factor a polynomial, the final answer is always a product. So there you have it. Again, from this example, we group terms together. So what's our goal? So that when we group terms together, we can apply our basic types of factoring. Let's proceed. Let's have another example here. Second example. So let's say we have the expression 6y squared minus 3y plus 2py minus p. Again, if you will inspect, do we have a common monomial factor? For the first three terms, we find y, but in the last term, we don't have y. Therefore, y is not a common monomial factor. For the numerical coefficients, none. Okay, so common monomials will not work. Difference of two squares will not work. This is not a trinomial, therefore perfect square trinomial and trial and error will not work. So we have to introduce factoring by grouping. So let's inspect. So for the first two terms, if you will inspect, for the first two terms, you will notice that y is common, while for the last two terms, p is common. So guys, it does not mean that we will always group the first two terms, we will always group the last two terms. In some polynomials, we will be needing rearrangement of elements so that we can group terms together. But for this example, we can group the first two terms together. So if I will now group the first two terms together, preceding it by a positive sign, so we just copy the elements. The last two terms, we can also precede it by a positive sign. So we just retain all the elements involved. Then after doing that, for the first two terms, again, we can factor out y. And in fact, we can also factor out 3. So applying common monomial factor, we can factor out 3y. And factoring out 3y, 6y squared divided by 3y will be 2y. And then minus 3y divided by 3y will be 1. And then for the last group, for the second group, we can factor out p. And factoring out p, that should leave us 2y minus 1. Then after doing that, notice 2y minus 1 is a common factor. So factoring out 2y minus 1, that will now give us. So if you divide the first term by 2y minus 1, that leaves us 3y plus. We divide this by 2y minus 1, that should leave us. So that will now be the final answer. Again, notice our final answer must be a product because we are instructed to factor our polynomial. That's the second example. Let's proceed. Another example. Third example, let's say we have x cubed minus x squared plus 3x plus x squared y minus xy plus 3y. So we have to observe, we have so many terms involved here. We have 1, 2, 3, 4, 5, 6 terms. For the first 5 terms, we can find x. But for the last term, we don't have the element x. So x is not a common monomial factor. So we cannot just apply common monomial factor. And then what else can we do here? Let's observe. Let's observe. Look at this. Look at this. For the last 3 terms, you will notice that y is common. And for the first 3 terms, x is common. Therefore, that should already give us a hint. We can group the first 3 elements together, preceding it by a positive sign. So we just copy the elements, inserting the sign of grouping. For the last 3 terms, let's also group them, preceding it by a positive sign. So all the terms will just be copied inside the sign of grouping. Then after that, let's proceed. Sabi natin, for the first 3 terms, x is a common factor. So factoring out x, that should give us x squared minus x plus 3 plus. For the last group or for the second group, y is a common factor. Factoring out y, that should leave us x squared minus y. That's x squared. We're factoring out y. So that should leave us x, not y. That should leave us x. And then factoring out y, that should leave us 3. Then, after factoring out x and y respectively from the first and second group, look at this. X squared minus x plus 3 is a common expression. Therefore, that is now a common factor using common monomial factor. That's when terms are grouped together, we treat that as a single element. So factoring out x squared minus x plus 3, dividing this by x squared minus x plus 3, that should leave us x plus, dividing this entire thing by x squared minus x plus 3, that should leave us y. So that will now be our final answer. Again, look at the final answer. It's a product because the instruction is to factor completely. Therefore, our final answer must be a product. So we have 3 examples there. Let's have another example. So let's say, what if our expression will now be something like this? We have a squared plus 2ab minus 9, and then let's say plus b squared. Okay, let's observe this. Do we find a common monomial factor? None. This is not a difference of two squares. We have 4 elements. We cannot apply perfect square trinomial. We cannot apply trial and error because we have 4 terms involved. We don't have a trinomial. Okay, so let's try to group terms together. So if we will imitate what we have done in the previous examples, for the first 2 terms, you will notice that A is common. Okay, so if we will imagine our solution, if we group the first 2 terms together, we can factor out A. Now, look at the remaining elements. For the last 2 terms, you do not find a common factor. Okay? So it means if you factor the first 2 elements together, A is a common factor, but if you will if you will group the last 2 terms together, you don't find a common factor. So it means we cannot just group the first 2 terms together. So we may rearrange. So if we will rearrange, so let's say we group the second and the fourth. We can factor out B. Okay, so we can factor out B. So that leaves us to group together first and the third. But grouping the first and third together, we do not have a common factor. Okay, but it's a difference of two squares. A squared minus 9. That will be A plus 3 times A minus 3. But then again, if you factor out B, in the second and the third, second and fourth, I mean, that leaves us 2a plus b multiplied by b. We don't find a common factor, 2a plus b. While if you factor out a squared minus 9 together, that gives us a plus 3, a minus 3, right? So, you don't find a common factor. So, again, that grouping will not work. So, what can we do here? Let's be observant. If you will observe, actually, we can group a squared, 2ab, and b squared together. Why? If you will group these 3 terms together, you will arrive at a perfect square trinomial. Okay? Obvious, it's a perfect square trinomial. And then that leaves us minus 9. Okay, so grouping a squared plus 2ab plus b squared together, preceding it by a positive sign. So we have a perfect square trinomial there. And if we will factor that perfect square trinomial, that leaves us a plus b, the quantity squared, because it's a perfect square trinomial. Minus, oh, if that's a perfect square trinomial, we create a perfect square, minus 9. But isn't it that 9 is the same as 3 squared? So why am I writing 9 as 3 squared? So that, if you will notice, the resulting expression is now a difference of 2 squares. A difference of 2 squares. Therefore, if that's a difference of 2 squares, this serves as the first term. So, if it is a difference of 2 squares, according to the rule is we get the first term plus the second term, right? Remember our formula? First term squared minus second term squared. The factored form of that is first term plus the second term multiplied by the first term, which is a plus b, minus the second term, which is. So that's a difference of 2 squares. And if we will just rewrite this, we just remove the sign of groupings. This is a plus b plus 3, and this is a plus b minus 3. And that will now be the factored form of our polynomial. Okay, next, let's look at another example. Let me write the polynomial. Next example, let's say we have 4x squared minus 16b squared plus 9y squared minus 12xy. Okay, let's be observant. We have we have to inspect carefully. We have x squared, we have y squared, we have xy. Since we have x squared, y squared, and xy, we might as well combine them together or group them together. If we will group those elements together, that should be 4x squared minus 12xy plus 9y squared. Okay, so before we proceed, if we will group those terms together, are we producing a perfect square trinomial? Square root of 4x squared is 2x. Square root of 9y squared is 3y. Times 2, we get 12xy. Okay, so obviously it's a perfect square trinomial. We have inspected it. And then that leaves us minus 16b squared. Okay, so after doing that, it is now a resemblance of the last example that we had. Factoring the perfect square trinomial. Factoring the perfect square trinomial. So, square root of 4x squared is 2x. The sign here is minus. Square root of 9y squared is 3y. Everything raised to 2. So, do you still remember that? We have discussed how to group a perfect square trinomial. And then minus 16b squared, we can write that as 4b, the quantity squared. And because of that procedure, we now get a difference of two squares. And since we have produced a difference of two squares, according to the rule, remember the rule of the difference of two squares, we have the first term squared minus the second term squared. If we will just go back to the formula, it's like we have a squared minus b squared is a plus b times a minus b. So, we have the first term, that's 2x minus 3y, plus the second term, which is 4b, multiplied by, we get the first term, which is 2x minus 3y. Let me erase this, change this, sorry. That should be 3y. That must be 3y. 3y. And then minus the second term, which is 4b. So that's a difference of two squares. First term squared minus second term squared is first term plus second term times first term minus second term. And then, just removing the signs of groupings, we have 2x minus 3y plus 4b multiplied by 2x minus 3y minus 4b. And that will now be our final answer. Again, look at the final answer. It is a product. So there you have it. The fifth example. Let's have another example. Let me just insert a slide here. Okay, there you go. Let's have this example. Example, Let's say we have 4x squared minus a squared minus 4ab minus 20x plus 25 minus 4b squared. Again, when you will be doing factoring by grouping, you really need to be very observant. You have to inspect the given polynomial very, very carefully and look at your polynomial given. If you will observe, we have here x squared, we have here x. So most likely, those two terms will go together. What other terms do we have in the expression? We have a squared, we have b squared, and then we find ab. So most likely, those three terms will go together. Therefore, 25 might as well go with the first two elements that we have identified. Okay, let's try to group those terms together. We are now grouping 4x squared minus 20x plus 25. And then, for the remaining three terms, since all the terms are negative, let's group them, but let's precede the group by a negative sign. So again, if it is preceded by a negative sign, we change the signs of all the elements from negative a squared, that becomes positive a squared, from negative 4ab, that becomes positive 4ab, from negative 4b squared, that becomes positive 4b squared. And then, what happens in this group? 4x squared plus 20x plus 25. Is this a perfect square trinomial? Okay, let's check. Square root of 4x squared, 2x. Square root of 25, 5. 2 times 2x times 5. That will be 20x. Okay, so it's a PST. How about this? Is this a PST? Square root of a squared, a. Square root of 4b squared is 2b. And then square root of times 2. So that will be 4ab, which is this element here. So this is also a perfect square trinomial. So we have two perfect square trinomials, and factoring each perfect square trinomial, what happens to the first? That's 2x minus 5, the quantity squared. That's 2x minus 5, the quantity squared, minus the quantity. How do we factor this? That's a plus 2b, the quantity squared. So remember, I have already discussed factoring perfect square trinomials. And then look at this. What's the result? The result now is a difference of two squares. It's a difference of two squares. Therefore, if it's a difference of two squares, first term squared minus second term squared. So, ang first term natin is 2x minus 5. Our second term is a plus 2b. And how do we factor a difference of two squares? We get the first term plus the second term multiplied by the first term, that's 2x minus 5, minus the second term, which is a plus 2b. So that's a difference of two squares. First term squared minus second term squared. Factoring that is first term plus second term times first term minus second term. And then, if we'll just remove some signs of groupings, what do we get? This is 2x minus 5 preceded by a positive sign. So we just remove the signs of groupings without changing the signs of the terms involved. That's 2x minus 5 preceded by a minus sign. So if we distribute the minus sign, that will be minus A minus 2B. And that will now be our final answer. The final answer is again A product. So there you have it, factoring by grouping. Again, factoring by grouping, the very crucial part here is how you inspect the elements. So the main goal for factoring by grouping is you group terms together in the original polynomial so that in the groups involved, you can now apply your basic factoring. And then after applying those basic factoring, the resulting expression must again be factored using still your basic factoring formulas, but this time you have some groups involved. Okay, so please review these problems. Again, in your module, you have some solved problems there. There are also some problems that are not yet solved that you can work on. So please be responsible to do those problems. So I am giving additional examples in my video lecture so that those problems in your modules can serve as review problems. Okay? So if you have questions, if you have clarifications, as I have mentioned to you before, you can just message me anytime. Just be patient in solving, and then I can get back to you through the messenger. So good day to everybody. Stay safe till our next video lecture.